Welcome to the Math 3 lesson summary video for the task Tracking the Tortoise. The purpose of this task is to extend the ideas of inverses to exponential functions. So previously in this module we've looked at inverses of linear, quadratic, and square root functions. So now we want to consider the question, what is the inverse of an exponential function? And to do that we're going back to Math 1 where we learned about Shelly the tortoise in a race against the hare and her path, which can be modeled by d of t equals 2 to the t power, where d is in meters and t is in seconds. So Shelly's been given a 1 meter head start since the hare was cocky, and her family has come along to watch her. So if we graph that d of t equals 2 to the t power, we will get a graph that looks like this. So three of the key points are at 0 seconds she had the 1 meter head start, at 5 seconds she will have traveled 32 meters because 2 to the 5th power is 32, and at 10 seconds she will have traveled 1,024 meters because 2 to the 10th power is 1,024. Couple key features of this graph that I want to point out. The domain is 0 to infinity and the range is 1 to infinity in this context because we're only looking at the first quadrant of positive time and distance values because that's what makes sense in this scenario. The entire graph of 2 to the t power, if we didn't restrict the domain, would be different. So then we have a different type of question. If the tortoise family wants to watch at 64 meters away from Shelly's starting point, how long will they have to wait to see her come past? So we can use the same graph and we look at the y-axis. So for example, it's y equals 64. If I extend that out, I can see that they'll have to wait 6 seconds. Similarly, if I use that same type of logic, y equals 1,024, I already know from the previous graph that that will take 10 seconds. I'm just reversing the way I'm thinking about it. Instead of substituting 10 into the equation to get 1024, I'm looking at 1024, the y value, and determining the x value. So we're inverting the way we're thinking about this, which is important. So that answered question 4. It would be 10 seconds. If I take this inverted thinking idea and I make a new graph where distance is the independent variable and time is the dependent, then I would get a graph that looks like this. So you can see some of the same points. At 32 meters, it's 5 seconds. At 64 meters, it's 6 seconds. But the points have been inverted from what we were looking at previously. And this is a graph that shows how long the tortoise family will have to wait to see Shelly run by a given location from her starting point. Notice now the domain is 1 to infinity and the range is 0 to infinity, which is switched from the previous domain and range before we inverted the graph. So we could use a graph like that to answer a question like number 6. How long must the family wait to see Shelly run by if they stand 220 meters away from her starting point? In other words, we're trying to answer the question, when is 2 to the x going to equal 220? Well, we know 2 to the 7th is 128 and 2 to the 8th is 256. And we know that 220 is in between those two values of 7 and 8. So when I'm looking at for the exponent that's going to solve this equation, I know it has to be between 7 and 8, but more likely closer to 8. So using guess and check a repeated number of times, I can arrive at this answer that they would have to wait 7.78136 seconds to see her run 220 meters from the starting point. Now, there's got to be a faster way to do this than guess and check. And that's what the purpose of this task is trying to get us to start to think about what would be a function way of representing the opposite of an exponential function. I couldn't just divide both sides by 2 like I would if this was 2 times x. I don't know the inverse operation of an exponential function. And that's what we're headed into in the next task. So this is just meant to whet your appetite. Again, if we consider the big picture of this task, we started off looking at distance versus time, where distance was dependent on time, and then the inverse, where time was dependent on distance. We can tell that these are inverses because each xy point, such as 4, 16, has been inverted or flipped. So 16, 4, xy became yx, which we know is one of the 3 key indicators of an inverse function relationship. So the question that this task should leave you thinking is, Well, if I have an f of x, which is 2 to the x, what would be f inverse of x? And how would we name this inverse function and this type of inverted thinking? And that will be continued in our next task. If you need help with the Ready, Set, Go problems for this task, please check out the Canvas site for your class and the Ready, Set, Go support videos located there.